Welcome to the recitation for Bioengineering 2020. We are solving simultaneous linear algebraic equations. They take the form ax equals b. Their expanded form, the a's are the coefficients. x1, x2 to xn are the unknowns, and the b vector are constants. Here's an example, the three equations and three unknowns. Let's solve this system of four equations and four unknowns. We're going to solve this by the method of elimination, and that's Gaussian elimination or forward elimination. First of all, we're going to rewrite the system in this augmented matrix form. This is so that we only keep the important information and we don't continue to copy the equations each time. So our goal with this is to get this side of the matrix A, in upper triangular form. So that is, everything below the diagonal should be zeros. So all of these coefficients we need to transform into zeros. We do that with row operations. And row operations that do not change the solution of the system. So those could be, we could exchange rows and not change the system, because we could swap one row for another one. We can multiply rows by a non-zero factor. Or we can add multiples of one row to another. So again, those are row operations. With the goal of obtaining an upper triangular matrix. Okay, so let's perform our first row operation. We would like to get a 0 in the 1, 2 spot coefficient. To do that, we can take a -2 times the first row and add it to the second row and replace the second row. So the first row isn't going to change. I'm going to copy that as it is. The second row is going to become 0, 2, 4, -2, and 8. Let's go through that. -2 times row 1, so -2 times 1 plus 2 is 0. -2 times a -1, 2, plus 0 is 2. -2 times a -1, 2, plus 2 is 4. -2 times 1 minus 2 plus 0 is a -2. And finally, the constant, -2 times 0 is 0, plus 8 is 8. And the final two rows don't change, so we're going to copy those over. And 3, -2, 4, and 7. Here's our new system. Now we're going to we'd like a 0 in the 1, 4 spot. To do that, we can take a -3 times row 1 add it to row 4, and replace row 4 with that result. Now what we're doing here is we're using the first row and the first, actually coefficient 1, 1, as a pivot. And that is, we're using this, this coefficient to get rid of anything, the coefficients below it. So let's do this operation. And again, the first 3 rows are not going to change, so I'm going to copy them right over. And then we'll do the 4th row transformation. 1, minus 1, minus 1, and 1 for the top row. 0, 2, 4, minus 2, and 8 for row 2. 0, minus 1, minus 2, 0, minus 8 for row 3. And now, minus 3 times 1 plus 3 is going to be 0. And we're going to get a 0 here. 1, 1, and 7. Now let's go through that. Minus 3 times row 1, we did this one. Minus 3 times a minus 1 is 3. Minus 3 is 0. Minus 3 times a minus 1 is 3. Minus 2 is 1. Minus 3 times 1 is minus 3. Plus 1 is plus 4 is 1. And the constant minus 3 times 0 is 0, plus 7 is 7. Okay, and next we'd like to get rid of this coefficient, the 3, 2. We'd like to put a 0 in that place. To do that, so notice we're not going back up to row 1 this time. We're going to use the number 2 here in the 2, 2 spot as our next pivot. So this was our first pivot, 1, 1. Now we're going to go to 2, 2 and use the 2 as our pivot to get rid of anything below it. So in this case, we're going to do a 1/2 row 2 now, plus row 3, and use that to replace row 3. So let's take a look at that. We're going to copy the first 2 rows again. They're not going to change. 1, minus 1, minus 1, 1, and 0, 0, 2, 4, minus 2, and 8. Now row 3. That's gonna, the 0 is going to be preserved, and we're going to say 1/2 times row 2 plus row 3, and that's 0 right here. And then we're going to have a 0, minus 1, and minus 4. Let's go through that. 1/2 times 4, 2, minus 2 is 0. 1/2 times a minus 2 is a minus 1, plus 1, plus 0 is a minus 1. And finally, 1/2 of 8 is 4, minus 8 is minus 4. And we're going to copy the final row over. It's not going to change. Next, we'd like a 0 in the 4, 3 coefficient. But we cannot use 0 as a pivot. Pivots cannot equal 0. But we can swap rows. We can exchange rows, as we talked about up here. So let's do a row exchange. So it'll be row 3 and row 4. Let's copy the first 2 rows. They're not going to change. Now, row 3 and row 4 are going to be swapped, so we're going to have 0, 0, 1, 1, 7, and 0, 0, 0, minus 1, and minus 4. And now we have our upper triangular form. So we can solve now with backward substitution. I'm going to go over that very quickly because we've seen an example of backward substitution. I'm just going to go quickly through it to get the final answer. Minus u equals minus 4. Remember, we start with the last equation. So u equals 4. One solution. We pop up to the third row. Z plus 4 equals 7. So z equals 3. We take these two solutions up to row 2. 2y plus 4z minus 2u equals 8. We know that this is 3, and we know that this is 4. So y equals 2. And finally, we take these three solutions, put them into the first equation, and we have x minus 2 minus 3 plus 4 equals 0. So x equals 1. And there's our solution for the four unknowns using the method of elimination, Gaussian or forward elimination, to get an upper triangular matrix, and then using backward substitution to get the final solutions.